Alright, hello, my name is Matthew Deptula, and this is the final project of the spring 2023 semester. This is Gadget Design Part 2, Creation. So, first off, define the problem. The main objective was for me to make a working portal radio. I split this up into two parts, functionality and creativity. Hint, hint, CS2 and IED. For functionality, I wanted it to work as a radio, have a catchy Portal song that played, and have Bluetooth functionality as well. For creativity, I wanted it to be accurate to the game, be able to adapt the parts I had into the design, and have a unique method of creation. Okay, so this is the design matrix I had. This is the only thing to generate concepts. This is for functionality. So I went through all my different options, Bluetooth, MP3, FM radio, and different combinations of that. And eventually I landed based on assigning ranks and multiplying them by a certain amount to get a value, a summed up value. I figured out my best choice was to do the MP3 and FM radio combination, which was 138 points in total. It won over everything else, so that's what I based the rest of my design off of. Design solution. These are basically all of my little parts that I used in my diagrams. So, first off is the Arduino Uno. It is a microcontroller with 14 digital input-output pins with 6 analog inputs, and it's pretty easy to use, or simple to use at least. The TEA5767 is a small compact FM radio module that can read or can listen from 72 megahertz to 108 megahertz. It comes with an antenna, which is very handy. The SSD 1306 is a 128 pixel by 32 pixel OLED display module. Very compact, very nice, and good for displaying the radio station. CYT 1100 is a rotary encoder that came with a handy little knob. The difference between a rotary encoder and a potentiometer is a continuous, actually it's not a continuous spin, but it doesn't click. It is just a smooth spin. But this actually is able to spin forever at a 360-degree rotation. And it clicks. It has different intervals, and it's a completely different system from a potentiometer. Very unique, very cool. The CF Player Mini is an SD card reader that is designed to play MP3 files. So you load up MP3 files on there, and it can send it to the Arduino and play it through a speaker. Then the speaker, of course, is a 4 ohm 1 watt speaker. I took this from actually an old radio. I have a picture of it right here. You can see it in the background right there. I took it from this old radio, and it works really well for the whole project. And there's some math behind the ohms and the wattage, but it worked out well, so I'm glad to have it. Lots of trial and error. Okay, this is the orthographic diagram. This is basically just showing you what the radio looks like from each side. Pretty cool. This is the components diagram. This is how I wanted to divide my components up in the design. So you can see we have the base, we have a front panel, and we have two main pieces that connect together that I called cover pieces. You can kind of see it. So one is on the front, one is on the back. This is the wiring diagram. I used a program called Fritzing to make this, very handy. I'll go into this more in detail in the build and test section, but this is what it would end up looking like, or what I wanted it to look like. This is my dimensions diagram. So my original idea was to have it 11.81 inches wide, 5.32 inches lengthwise, and 7.48 inches tall. The actual design came out to be about, I ended up correcting this to about 8 inches wide, 4 inches lengthwise, and maybe about 6 inches tall, just because there wasn't enough space. It was a little bit too big. This is my Scrum chart. This would eventually end up becoming the Gantt chart. This is actually just ripped from the proposal. So, of course, all of this is done now. But this morphs into the Gantt chart, and this is my project timeline. I'd say at the beginning I did a decent job of following this, but towards the end it definitely went off the walls. But this is my original idea I wanted for the Gantt chart, and so I took all of these and put them into a chart of timelines. And of course, today is the 8th. This is the final day of the project. We got like 4 months to work on this. So this is the the Fusion 360 models that I came up with. Unfortunately, I didn't make much headway in the terms of actually creating the actual structure of the radio. However, this is the designs I came up with. I'm very proud of myself for the dome you see on the left. That was hard to make. It's a complex shape. On the top right is a module that I wanted to use so that I could put the little power switch into it. And I actually have it right here. That actually worked out. I don't know if you can see that, but yeah, I put the power switch into that just like that. And then the last thing is an Arduino mounting thing that I made. I didn't end up using it, but it was a pretty cool side project. And you can mount and screw an Arduino onto it, so it's pretty cool. And that's all I did in Fusion 360 for this particular project, unfortunately. However, in the code, I made a lot more leeway. So this is the flowcharts for each part of the Arduino code. It works when it's initialized, it runs a setup, and then it'll always from then on it'll just loop until the cycle's broken. And so with the setup, the flowchart is that it would begin just monitoring the pin input. It's pretty simple. That's it. But for the loop, what it's doing is it's reading the potentiometer, saying is the value different from the last value, and if it is, then, or I'm sorry, it's not reading the potentiometer, it's reading the rotary encoder. But if it is different than the last value, it'll update the radio frequency in, it would actually not break, it would loop back. But that's basically the general idea. This is the code for that. I won't go into super big detail. Basically, it's just identifying all the pins for the setup and beginning an output on the console. The serial console is what it's called with Arduino code. And this is the loop function. There's a lot more here, but basically what it's doing is it's taking the input value from the rotary encoder from a certain range of numbers, and it's using math and it's converting that to the range that the FM radio module could read. So it was doing that all through math, and then it was displaying it on the display. Unfortunately, I had some conflicting signal issues, an analog signal or something. So the radio signal would actually come out very distorted if I used the display. So I actually ended up, well, I used it at first, but I was having issues, so I stopped using the display. So this is the circuit diagram here. Once again, fritzing, what a great program. It helps so much, and everything in here is accurate. Everything in here I actually did use, except for, I guess, that switch. It isn't exactly the one I used. Basically, the way it works is you have a 9-volt battery input, or actually 6-volt, but the 9-volt was the best I could find in this program. And going to a power switch, and then a rotary encoder was hooked up to the Arduino, and whenever it updated the radio, it would send the signal to the radio and the display, and then through the radio, it would the left and right channels would go through a potentiometer, which would increase the signal strength, and then that would go through a amplifier, so really increase the signal strength. So the potentiometer actually worked as a volume knob, and then that would go out to the speaker. Very cool system, and I learned a lot in this process. So this video, I'm actually going to show it to you in OBS here. This is basically the actual what it looked like in real life. So you can see I turn on the power switch here, everything comes on, and then this is the volume knob, so it's very staticky and loud right now. You probably can barely hear me. And then after that, I have the radio start playing, and then now it's playing, and I get it tuned. I think it might be 89.5 or whatever this is. And I get it tuned, and it's actually a decent signal. You hear some popping in the background. That's from the code being sent over and over again. You can hear a little popping from that. It's very interesting. So that's that video. And finally, my evaluate solution. The key takeaways I got from this project was, yes, it was harder than it looked. There was a lot of learning involved with circuitry and 3D modeling that I've never done before, especially going back to Fusion 360 since first semester. A lot of new stuff, but I learned so much. Careful with my money. I spent some extra money that I probably didn't need to spend on this project on extra parts, so now I'm just going to have all these extra Arduino parts sitting around, and maybe I'll be able to use them in the future, but just be careful with how you spend your money on this kind of project, especially a school project. Do what I can. I really did try to do what I could. There was a certain point of complexity on the Fusion 360 that I wasn't sure if I had the time and the energy to do, so this late in the project, I decided to just stick with what I had, and you know what, that's the best. That's always the best. Just polishing what you have instead of always trying to add new stuff. And then finally, be proud of what I learned. So I mentioned this. I've learned so much, and I'm very proud. I think I'm very proud of myself for actually learning how to code an Arduino and learning how to wire things. I've never done anything like it before. So it's all very new, and I'm very happy with what I learned from this project and this year in general. It was a fun class. Anyway, that's all for my presentation. Thank you for watching.